Yeah, it's been a tough year to run intervals due to the weather. Okay, here we go. Components of vectors. Okay, so if you want to calculate the component of u ln v, you can take u times v divided by the magnitude of v. What does that mean? Okay, so this this vector right here, I have vector u and I have vector v, right? Well, this vector u has a component. It has two components. I will say that it has this component, we'll call it the vertical component, and it has this component, we'll call it the horizontal component. And the component of u along v, okay, so the part that resides right along vector v is equal to, as we said, u times v, so you multiply the two vectors using dot product property, divided by the magnitude of v. So that's just a formula. And I'm exposing you to that. We're not really going to use that much. I want you to see it in case you get in physics class or somewhere else. We're going to solve our stuff using kind of an easier property, okay? So let's try this. It'll be really straightforward. Find the component of u along v. Remember that that's going to be equal to u times v divided by the magnitude of v. All right, so how do you multiply two vectors again? What do I do? Multiply the x values, so I get -1 plus 4 times 2 is 8. So that's u times v, right? Divided by the magnitude of v. How do I find the magnitude of a vector? Square root of a squared plus b squared. So if I take the square root of -1 squared plus 2 squared, I get square root of 5. So on top you have 7, bottom you have square root of 5. Multiply top and bottom by square root of 5, and you get 7 square roots of 5 over 5. So that's the component of u along v. That's it. Billy Barber asked the question. Okay. All right, so if I've got it in terms of I and j, I go 3, -1, and I do 1, 1. So I'm going to multiply the vectors using the dot product. 3 times 1 is 3. -1 times 1 is -1. I'm going to divide that by the magnitude of v. What's the magnitude of v? Square root of 2, which is equal to 2 over the square root of 2. If you reduce that, you get square root of 2. Easy peasy. Any questions on that? Let's move along. A truck weighing 4,000 pounds is parked on a driveway that is inclined 30 degrees to the horizontal. This is a question which you will get on your test, okay? Very, very similar in design, okay? So you want to be ready for this, okay? So I have a horizontal, and I've got this driveway that has a 30 degree incline. I have my truck. Don't laugh at my drawing. Thank you. Thank you. I've been working on my car drawing. Wow. Thank you. May I please have another insult, Casey Gilbertson? I will, next time I get my haircut, I'll ask you what you truly think. Who was it the other day? I said I got my hair cut, and then somebody paused and I said, "Did you realize you're losing your hair more and more every day?" It's like, no, I thought it was all of a sudden growing back. Told my wife that, she laughed. Okay, so let's look at this. This is the correct depiction. Now, this car weighs 4,000 pounds. Would you agree that the force of gravity is perpendicular to the horizontal surface of the Earth? So if this dotted line represents the horizontal surface of the Earth, then this vector would look like that, and it would be 4,000 pounds. So I'm going to represent that vector with a magnitude of 4,000. Everybody okay? Ton is 2,000. So if that's my truck, this truck has different components of force. Number one, if you think about it, that truck might want to roll backwards, right? And so I have this component. And then I have another component, which is the green one is the force against the driveway. So that's what the driveway is experiencing. Okay? The red one is the force required to try to keep the truck from rolling backwards. So for example, here's a good question. If there's a 30-degree incline, do you think you could stand there? Let's say the truck does not have a brake. Do you think you could stand there and hold the truck and keep it from moving back? You don't? We won't know until we figure out that component of the force. So the question is, find the magnitude of the force required to prevent the car from falling down the driveway. That's the red vector. And I want you to see that we can make a very simple triangle out of this, okay? Now, would you guys agree that that green vector is going to be the same as this green vector right here? Whoop, it's supposed to be green. Would you guys agree? Now, if this is a 30-degree angle here, okay, what's this angle right here? 60. And we know that this is 90, and we know that this is 30 degrees. So I have a triangle right there, and I'm going to represent that triangle right up above. I have that, the black vector, which is 4,000. Then I have the red vector, which we said is the force that we need to have in order to keep the truck from rolling backwards. And then we have this green vector, which is really the force against the driveway, okay? And I do have an angle. It says that theta is going to be 60 degrees here, okay? So do you know enough about SOHCAHTOA in order to solve for the red portion? We'll call the red portion H for horizontal. We'll call the green portion V for vertical. Can somebody set up a ratio for me? Yep, very good. Cosine of 60 is equal to H over what? 4,000. The cosine of 60 is 1/2. So multiply both sides by 1/2, you get 2,000 is equal to H. So magnitude of the force, 2,000 pounds. That's what we would need to put forth. Do you think you can exert a force of 2,000 pounds? Probably not. But, you know, if you just put like a block of wood behind that wheel, that might be enough. You guys, you remember before I've tried to lock you in here, and you know you can have about 5 people push against the door. If I just put my foot up against it, it's really hard to move that door. And so, I might not be able to push with my hands and exert a lot of force, but with a little bit more leverage and friction and stuff, you could probably get something to work. So, but you would want to use that information in order to figure out a proper emergency brake. Let's do the next one. If we want to figure out V, instead of using cosine, we use sine. So you would have 4,000 times the sine of 60 is equal to your vertical. And sine of 60 is the square root of 3 over 2. So 4,000 times the square root of 3 over 2 is equal to 2,000 square roots of 3. And you don't have to leave the answer like that on your test. You could go ahead and you could go ahead and make that into a decimal. Any questions how I figured those out? Which part? You see where I got this horizontal? See where I got the 30-degree incline? Okay, then what I start with is this black line because it goes weight, okay, it weighs 4,000 pounds, is going to go perpendicular to the horizontal. Now, I know I have that, but I have a force right along this vector right here, okay, the red vector. And that's going to represent, well, let's just say that this green vector represents, the vertical component of the black. The red represents the horizontal component of the black. I just transferred this green one over to that. So nope. Okay. All right. Take this, calculating projections, and cross it off. This is interesting to study, but you won't really use it in mathematics. You would maybe use it in physics class. So that just brings us to this last part. And work. Work is defined by force times distance. So what we want to do is we want to find the work done by the force F in moving an object from P to Q. And so we have to figure out two things. Number one, we have to figure out the force. Number two, we have to figure out the distance traveled. So let's figure out the distance first. The distance between 2 points I can express in component form of a vector by simply subtracting the x values and subtracting the y values. So the distance is going to be 3 minus 0. That will be the horizontal component. The vertical component will be 4 minus 0. And so we get 3, 4. So that is my distance vector. Everybody got that? Times. The force vector is I plus j, or 1, 1. Now I'm going to multiply those. 1 times 3 plus 1 times 4 is 7. So 7 is the force required, or is the work done by the force moving an object from P to Q. Is that pretty straightforward? Let's look at this one. How do you write the force in component form? 3, negative 2. Now, if you want to figure out the distance, I've got to come up with a vector in component form. Negative 1. What? Negative 1. You subtract them, right? So if you want to know the distance from P to Q, you'd subtract the x values, subtract the y values, and that will put it in component form. That's the distance in component form, yeah. Okay, that was one of the first things we learned. Yeah. Okay, so now we multiply these, and 3 times -1 is -3, plus -2 times -1 is 2, and we get -1. How could work be negative? It moves it in the negative direction. So because work involves vectors and vectors are allowed to have direction, you could end up with a negative result. Okay. All right, so let's go to a real life example. It says a lawnmower is being pushed a distance of 80 feet with a constant force of 60 pounds on the handle. The handle's at 35-degree angle to the ground. Find the work being done. So I have a lawnmower. I have the lawn. Okay. And it says that the handle is at a 35-degree angle to the ground. So this is 35 degrees. So I have what I would call a vertical component, and I have what I would call a horizontal component. The lawnmower goes from this point to this point. And what's the distance of its travel? 80. So what I need to do is set up an equation. And the equation is very simple. Work is equal to force times distance. What would you like to figure out first? You decide. Force? Okay. So we're going to figure out force. Well, force has a horizontal component and a vertical component. We know that the force exerted on the handle is going to be 60 pounds, and it's constant, which is good. So in order to figure out a little bit more information here, as far as the component form of that vector for force, I have to know this vertical component and this horizontal component. Help me solve for it. We'll call this H, we'll call this V. This is basic trig, SOHCAHTOA. Sine of 35 equals V over 60. Multiply by 60. Can somebody give me a result? And cosine of 35 is equal to H over 60. And I wrote that 3441 in the wrong spot. It should be the vertical part, sorry. You got the other one? 60 times cosine 35. So there's our force component vector. Any questions how I got that? Okay, so I got to multiply that by the distance vector. If I move from here to here, what's the vector? 80, 0. Very good. All I have to do is just figure out my two vectors in component form and multiply them together. Now in your study guide, you're actually going to push it up a ramp. Yep. That'll be more challenging. Yep. So, all right. What do you got? We got multiply this. So I got 49.15 times 80. Plus, what's 34.41 times 0? 0. So look at what you have. This should make sense. Is the lawnmower moving vertically at all? So is there any vertical work being done? No, so you have 0 for that component. So you add them together and you do get the 3,932, and we call this foot pounds. That's how we measure. That's how we measure work in this situation. Okay, last portion. Okay. Cars on a driveway, it's inclined, so we've already done one like this. We're going to practice one more, which is good. Tyler had a question on it before. We'll see if this can kind of shore things up a little bit. So I've got 12 degrees, and I've got a car that weighs, I'm going to turn it into a truck because I can do that, weighs 3,200 pounds. So I have a force that's going straight down perpendicular to the horizontal of 3,200. The question is the force required to keep it from rolling down the hill. So this is the question that Tyler asked earlier that we want to try to diagram. Which vector do I draw to represent force required to keep it from rolling down the hill? Yeah. I'm also going, so I only need to find the red vector. The green vector represents the force exerted against the driveway. I'm just drawing that so that, you know, in case you have that question in your assignment. She wanted to come and bug me again. Okay, so I need an angle. What's this angle right here? What's this angle? We need that angle. 78. Okay, so I'm going to, this is 3,200. So I need to figure out the red we said. So I'm going to go ahead and do that. And I'm going to call that H for horizontal. So I have the 3,200 times the cosine of 78 degrees is equal to H. Somebody have an answer. 665.32 pounds of force. Now, could you exert 665 pounds? No, but you definitely could with a block load or something. That would definitely be attainable. Not that big of a deal. Okay. So, that's it. That covers all the content that you're going to have in this test. You have 2 full days of class time to prepare for it. You have a whole weekend to go over your stuff. You have access to videos. If you didn't do so well in the last test, don't worry. Everybody has a bad test from time to time. Do well on this one because you only have 3 sections. You've got a lot of time to ask me questions. Do not procrastinate. Okay? Get to work. Here's your assignment. There you go.